Okay, we got another interesting integral here. We get an integral from 0 to 1, x to the 29th, 1 minus x to the 20th to the 50th. Now, of course, you may be tempted to just multiply this out, 1 minus x to the 20th to the 50th, but that's going to be a lot of work, so let's skip that. What we're going to do instead is use the beta function. And you notice this would be fine, but we have a problem, right? We got this 20th power here, and that's going to kind of mess up our whole plan. So what we need to do is deal with that. And what I can do is we'll make a u substitution, and that's going to be our way to handle that, because the beta function is assuming that the power here is going to be 1. And so we got this 20th power. So let's deal with that with the u substitution right away. So we're going to say u equals x to the 20th, and then du is going to be, taking the derivative, is going to be 20x to the 19th dx. Okay, and we'll make that, actually before we do the substitution, let's actually solve for dx. So we're going to get du over 20x to the 19. And then when I make the substitution, I'm going to take my 1 over 20 and bring it out front. All right. And then we'll plugging in 1 here, we're going to have 1. Plugging in 0, we're going to have 0. I'm going to leave this in terms of x for the, we're making our substitution, but I'm going to leave some x terms in, and we'll just deal with that later. And that's totally fine. We're going to have this x 19th over here. This is going to become 1 minus u with our substitution. 50 stays the same. We have our du. Now dividing here, we're going to have x to the 10th. All right. Now the thing to notice, our substitution was for u equals x to the 20th. The square root of u is x to the 10th, right? Taking a half, we take a half power here, we get our x to the 10th. So let's do a quick rewrite. We'll have our 1 over 20. Okay, but our x to the 10 we'll write, instead of writing a square root, we'll write it as u to the 1/2. Then we'll have 1 minus u, still to the 50. Okay, and at this point, the thing to notice is that we've really taken care of restoration, right? We get that 1 power. So we're in the form of the beta function, and we have our powers here. We don't want to forget about our 1 over 20. Now we can use our formula for the beta function. I'm not even going to write it out. We're just going to kind of go right to it. So we're going to keep our 1 over 20. Now, the way the formula works is it's 1 greater than these powers. So it's going to be, so for our first value, like our z1 value, it's going to be 1/2 plus 1. So we're going to be looking for the gamma of 3/2. Then 1 plus here, so we're going to have gamma of 51. And then we're just going to sum these two values together, 51 plus 3/2. I'm going to write this as 52 plus 1/2. And then from here, it's just kind of a matter of how much simplification you want to do, because these numbers are going to be too large. Like gamma 51 is 50 factorial. It's going to be too much to deal with. So let's see if we can get a little simplification. Gamma of 3/2 is actually square root of pi over 2. Okay. Gamma 51, we subtract 1, and we're looking at just 50 factorial. Now for this value, we have a formula. Let's just take a look at that real quick. So this formula, let me see. So if we have gamma of n plus 1/2, that's going to be 2n factorial square root of pi over n factorial 2 to the 2n. Some people write this as 4 to the n. I know that's probably more popular, but I like to write it as 2 to the 2n. Let's just kind of use this and see where it goes. So 2n is going to be 104. So we're going to have 104 factorial. We're going to have our square root of pi. And then this stuff in the denominator, I'm going to bring it up into the numerator. So our n value is 52. So we're going to have a 52 factorial, and then 2 to the 2n is going to be, yeah, I'm kind of running out of space over there. So I'm going to write it as, right over here, 2 to the 104. Okay, as far as just cleaning this up, I'm not going to go too crazy with it. But one thing we can do for sure is we can cancel our square root of pi's. That's really nice to just kind of get that out of there. Then I think I'll take this 2 and cancel it here, just out of one of these 2's. I wonder if we can probably do more with this here. So like 20 is 2 squared times 5. So we can take another 2 out of here. What else? I think I might just leave that. So like, okay, we got our 5 there. So I'll write it as 1/5 times 2 to the 101 50 factorial times 52 factorial over 104 factorial. I mean, obviously you could do some more canceling and stuff, but I'm not sure. It's just, at some point it's just going to be a lot of work. So let's just leave it and we'll write our solution that way. So we'll stop it there. Pretty fun with the beta function. Have a good day.